Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on outliers. So an outlier is a score in a set of data that's odd, and it's odd because it's much larger or smaller than other scores. So a data set can have more than one outlier. So before I go through examples of outliers, let's just look at this set of data here. 5 scores. Let's calculate the mean, median, mode, and range. So recall, to calculate the mean of a set of data, you add up all the scores and divide by how many. So if I add up all these scores, I get 347. I divide by 5 because there are 5 scores. So putting that on my calculator, I would get a mean of 69.6. So if I wanted to calculate the median of the data, remember the data has to be in order from smallest to largest. So I'd write 65 first, the smallest one, then 68, 70, and the 272s. Now, because there is an odd number of scores, there are 5 scores, the median will be one of the scores, it's just 70. So as for the mode is the most common score, so 72 was the only score that occurred more than once, so the mode here is 72. Alright, that's all well and good. You probably knew how to do that before this video. So let's say that these are test scores, and let's say that another student, a really smart student, probably named Alex or something like that, because smart kids always seem to be named Alex. So let's say that Alex took the test and he scored 100. So you can see this score is much larger than all of the others. All these scores are pretty close together. You know, all these students did pretty well on the test, they did alright, but then Alex came and he just did awesome. He scored much more than anyone else. So this score here is what we refer to as an outlier, much larger than the rest of it. So now that Alex has come and added his score into this set of data, let's recalculate the mean, median, and mode. So the new sum of all the scores, well, it was 347. It's now 447, and there are 6 scores. So putting that in a calculator, we get 74.5. Now again, if I wanted to calculate the median, I need to put the data in order from smallest to largest. So it would be the same as this, but just with 100 on the end. So now we have 6 scores. The median will be in the middle of 2 scores. The median will be here, the average of 70 and 72. So I add them up, divide by 2. The median is 71. So there are the same number of scores above the median as below it. Median now 71. The mode actually won't change at all. So the mode is still 72. It's the only score that occurred more than once. So what we can see here is when we add the outlier, look at how much the mean's gone up. The mean's gone up almost 5, the median only went up by 1, and the mode didn't change at all. So, of the 3 measures of central tendency, these ones here, the mean is most susceptible to outliers. An outlier has a greater effect on the mean than on the median or the mode. Now, the reason for that is when we calculate the mean, we use all of these scores to calculate the mean. When we calculate the median, we're only interested in the middle score. We don't even care about the outlier. And same for the mode. We don't care about the outlier, we just care about which scores are most common. So that's why, if there is an outlier, it tends to affect the mean more than it does the median or the mode. Now, if I were to calculate the range of both data sets, we'd see a similar story to the mean. So, the range of this data of just the 5 red numbers is 72 minus 65. So, the range is 7. But if I add in the outlier, which is 100, the range is now much larger. Its now largest score is 100, minus the smallest score of 65, it's now 35. So the range is also very susceptible to outliers. Outliers have a big effect on the range. But remember, the range is not a measure of central tendency. It's a measure of spread. So what this all means is if you have a data set that has outliers, the mean may not be a reliable indicator of the center, and the range may not be a reliable indicator of the spread. So let's now look at an example of that. So an example of data sets in which there are outliers are house prices. Because most houses cost a similar amount. Most houses cost, 500,000, 600,000 at the moment. And you know this, if you just drive around Canberra, you'll see, a lot of average houses. But every now and then you'll see an outlier. You'll see a house that is worth heaps, could be in the millions. So if I were to write down, the cost of each house in Canberra, there would be some outliers. There would be some houses that are just way more expensive than the other houses in Canberra. So because there are outliers, and because of what we discussed on the previous slide, we found that the mean is more susceptible to outliers. It's more affected by the outliers. The mean is not a good indication of the average or the typical house price in Canberra. These houses that are worth millions, they would increase the mean greatly. So the mean would actually be greater than your normal house price. So when a data set has outliers, the median is a better measure of center than is the mean. The median gives you a more reliable estimate of the typical house price than the mean does. And that's because, as I showed you on the previous slide, the median is not as affected by outliers. So all these houses that are worth millions and millions of dollars, they would drag the mean up quite a lot. The mean house price would go up a lot, but the median house price wouldn't go up by much because of the outliers, because of those few houses in Canberra that are worth millions and millions. So because of that, when you hear the news talk about house prices, as they do a lot, they talk about the median house price and they never mention the mean house price. And the reason for that is because the median house price will give the people watching a better indication what's the cost of a typical house than a mean. Because the mean, if they were to talk about it, would be a lot higher than a normal house because of the outliers. These houses that cost millions would drag up the mean a lot. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.